Hi, I'm going to give an intro to air quality and how to quantify it in R. I live in Utah, and in the Utah Valley we have something called the inversion. Basically it looks like this. The cold air gets trapped in the valley, which also traps all of the pollutants. Fortunately, we can go to the EPA website, which has data sets to download for air quality across the entire United States. In particular, we're going to be looking at the particulates in the air. Let's go to the daily summaries. Since I'm going to be analyzing this in R, I'm going to copy the location of the metric PM 2.5 for the year 2013. Let's go ahead and open R using RStudio. We're going to create a new script. Let's start by downloading the CSV into our working directory. Remember, this zip file contains the metrics summarized by day for several locations across the entire United States. Still, this is just tip of the iceberg of data that we can analyze. Let's unzip that file. That file contained a CSV file that we can read directly into R using read.csv. Let's look at some of the columns that are inside this file. There's 28 variables, and these include things like state code, details about the site, its location, and what observation we have, as well as the different methods. Since I'm concerned just about Utah, we're going to subset this data set. Here I've subsetted the dataset just to the observations that are in Utah. Let's take a look at some of the columns in this. So inside this dataset we have things like the observation itself, which is a numeric, as well as the date that it was observed. Let's make sure we convert that date into an actual date. You can also summarize the dataset using the summary command. I find it very interesting to compare the distributions of the metric that we're concerned across an interesting variable. For example, For example, here we have broken out by state the observation of the metric PM 2.5. Notice that some cities have very high distributions, but for the most part, for the entire year, they have a very similar distribution. Let's look at just one city for the entire year. Let's get a list of the city names that we can choose from. Let's take a look at just Salt Lake City. I'm again going to subset the data set just for Salt Lake City. With just that subset of data set, I'm going to plot it over time. Here for the year 2013, we can see the PM 2.5 levels for Salt Lake City. Notice these extremes during the cold winter months. This is the inversion quantified. Now that you can quantify Utah's air quality, let's do something about it.